Hi, everybody, and welcome to our roof webinar. It'll be about 30 minutes today. Rael Levin is going to be the host. You can see him. He's going to teach you everything you ever needed to know about roofs. And there is a space in the bottom where you can leave some questions. And so after the 30-minute webinar, he will stick around and answer all of your questions. If you don't know Rael, he is a wealth of knowledge. He was in the construction business for a number of years, then a home inspector for over 15. He's ASHI certified. So if you have seen something on a roof, he has seen it many, many times over. So I'm going to let Rael take it away. And again, if you have any questions, just put them in the Q&A. And we will have a recording of this. If you missed anything or you want to look at it later, I'll be sure to send you that link. And we're doing another webinar tomorrow on the electrical part of the house. So if you go to Home Probe Academy, you can sign up for that one too. So thanks for joining us, and go ahead, Rael. Except Rael, you're on mute.
That might be a shocking experience tomorrow, but let's deal with roofs today. So welcome everybody. I'm going to share my screen in just a second and we'll get the slideshow going. Almost 4,000 inspections over the years that I've been with Home Probe, and it's really wonderful when you can work with people and in a company that gives you so much joy to go to work every day, and that's been my experience at Home Probe. So no longer doing the inspections personally, but now doing these webinars and teaching CE classes. So we hope we'll see you, through the time going forward. To give you your CEs through the Home Probe Academy. Okay, let's share the screen and we'll start off right here. And we are ready to go. Okay, so we're going to deal with all the different types of roofs. We'll show the photographs of them, the issues that come up with the different products that we see on the roofs. We'll discuss actually physically getting on that roof and all those fun things. Okay, so simplest roof, of course, is the flat roof. And if you see this particular slide, you'll see that we have a flat roof here, and the little built-up wall that goes around it is called a parapet. And these are really common down in the Emory area, around Emory University, and Grant Park area, but they all do suffer from installation and maintenance related issues. So here we're looking at, okay, we have a flat roof. This one's got a gravel buildup on it. And you can see over here in the bottom, there's a downspout, which is actually a scupper. So basically the water would run off the roof down into these gutters here and away from the building. You can see that there are others that are slightly above, about 2 inches above the membrane exactly. Just in case something over here got obstructed, there would be a secondary exit point for any water that might be on that roof, and the water would be able to get out of there. And again, as with most things in life and most products, maintenance is a big issue. And we're not going to run our motor vehicles without changing the oil or making sure the tires are in good shape. And it's the same thing with our home, except with our home, we tend to think of, well, it's big, it's there, we're coming home, we're busy, we got dinner to make, we got places to go, errands to run, and therefore the home kind of suffers from a lack of maintenance. And in typical here on a flat roof, if you're anywhere near areas where there are a lot of trees, the leaves and the debris that come off the trees would tend to land on this roof and clog up the gutters, and therefore you would have a situation where you could have a leak. So let's just look at an example here. See, you're a 20-foot by 20-foot square building here. So that's 400 square feet. With 1 inch deep of depth of water that's accumulated on there, we're actually looking at 1 ton of weight that's actually sitting on top of that building. The building structure, for the most part, over all the years has been wood, and with all this weight that sits on top of the home, when you have that weight sitting there, the wood would tend to give, and we would have a situation of some settling on the top of the roof. So here we're looking at sort of the clogged drain that would have the debris, as you can see right here, and the water is ponding on each side. And because it's ponding, it's causing that weight to put extra stress on the structure. If you all have ever seen the homes, especially the older homes, there was not a requirement until about maybe 15 or 20 years ago that said that the maximum amount of roof shingle that you can put on is 1 layer. So we'll see a slide of that in just a moment, but just imagine that the structure in the roof back in the old days was a 2x4. So it was a 4-inch piece of lumber, and it went from the very ridge of the home all the way to the outside wall. And the actual rafters were placed approximately 2 feet apart. And on top of that, they had, instead of the plywood or the wafer board that we use today, we had planks. And the planks might have been 6, 8, or 10, or even 12 inches wide. They were 3/4 inches thick. So those in themselves were pretty heavy for the sheathing. On top of that would come the asphalt shingle. And if somebody had a leak, they would just put on a second roof on top of the first without taking the first roof off. And that put even more weight on top of that structure, which caused the actual rafters to kind of bow in, to sag. And we could see that. We'd walk up to a home and you would see the sag in that roof line, and you figured, well, okay, when I get into that attic, we can see what's up in there, and perhaps make a suggestion on how that could be taken care of, repaired, and restored, to straightening it out by installing an cripple wall or a little sub wall, sort of perhaps halfway down on the span of that 2x4 rafter. That would be pretty common. But again, the actual cost of doing a lot of this work is the removal of the shingle that's up there, and then coming in and jacking up or straightening out those rafters to get the desired effect. So you can see right here how the water has been ponding and it's pushing down on the roof joists. And as they sag, more and more water so it's an ongoing thing. And as more water is going to be ponding, so the roof joists are going to be sagging and sagging and sagging. So the water wouldn't even run over to the roof drain here anymore. So how would we handle this? Well, we would go ahead and put in a new roof drain. So it would be one on each side perhaps, and it would go down below here and out through the side wall and on down to the new downspout on the exterior. So that would be a fairly inexpensive way of dealing with the issue of that sagging rafter on a flat roof. Okay, so simplest roofs that we see are the shed roofs. And as long as they've got a pretty good slope on them, we're okay with putting just 3-tab shingles on them. If it's a lower slope, then we want to put in something like a roll roofing or an EPDM, which we'll cover in just a moment. I mean, this is very common. If anybody watches the show Building Off the Grid out in Alaska, or up in the mountains up in the Northeast and Northwest, that was a pretty common roof. Usually it was not going to be made out of asphalt shingle. It would have been metal. It's a great show to watch, Building Off the Grid. So by all means, check that out. So we're looking at the gabled roof, and they can be symmetric or asymmetric. So this is just a typical gabled roof right here. It's really, really common that we see gabled roofs in our area. Then we come in with the hip roof, and that's just a 4-sided roof right here. In this particular case, if you notice, there are no gutters or fascia boards on this particular building, and that was really common. The actual overhangs were extended more than 24 inches away from the home, and the water basically ran off and hit the ground. The issue that we would have with that would be that with that water collecting around the base of the home, there would likely be some water intrusion to your crawl space or into your basement at some point. Then we have the mansard roof, which is also what we know as a Dutch colonial. And in a case of the mansard roof, there are plenty of them out here in Dunwoody, where I am. And basically, they've got kind of a lower slope on the top, but the shingles run down the side of the home. And folks have been figuring out for years, because of the actual material, the heat buildup in this attic area on the second floor area of the home would be pretty big. So folks are changing them as the roof shingles are wearing out. The new method that we're seeing is actually installation of a hardy plank or cement-based siding, horizontal siding, put in here with some house wrap on it, and that seems to help the issue of the heat buildup in that space because of that asphalt shingle on the side of the home. Then we have the gambrel roof, which has got a bit of a sharper gable right here. And in a case like this, just to kind of mention right up front before we even get into it in any detail, something like this roof would be very difficult to access from ground level with a ladder. It's extremely steep and not exactly a safe way of actually accessing this roof here for inspection. So let's deal with the different types of roofing materials. The EPDM, the life expectancy is 20 to 35 years. I can't even say the words of what the EPDM is yet, so I have a little slide of that. The roll roofing is very common on flatter roofs. 10 years is the life expectancy. We've got a 3-tab asphalt shingle, and the life expectancy there is 10 to 15. That's about the most common that we see in housing around our area. We have the architectural shingle, which is 15 to 20 years life expectancy. And then we've got some of the stuff like slate, 75 to 200 years, depending on the type. We've got some clay tiles, 50 to 100 years. And what we're seeing a resurgence of in the last 2 years are the metal roofs, and they're 40 to 70 years, depending on the thickness of the metal that is applied. So the EPDM actually is a durable synthetic rubber roofing membrane. So here's the actual, what does the EPDM stand for? Ethylene propylene diene terpolymer. So I prefer EPDM, and it's used widely on low slope roofs around our area, really right throughout the United States. So you can see it's a good, it goes up the sides of this particular parapet. We're on the top of a commercial building here, and that's the way it's done. So, and it all again depends on installation. We can all again get into the modified bitumen roof. This is pretty much like what we would call roll roofing. You can see the item here says seams may be mopped or torched, and they're overlapped about 3 inches approximately over the preceding layer that's laid out there. They're never going to be installed in a straight line where the seam is. They always would need to be staggered to prevent water actually in getting in there. It's a very simple product for handy people to install, but if it's not installed right, it can be a major issue. The biggest thing about this installation is that you want to make sure that these edges are properly sealed down. When they don't lay down flat and correctly, there will be air bubbles in here, which again would provide access for any water that would accumulate on the top of this roof. So here we can see how it's laid out. It just rolls and rolls and rolls. And you can come on in and put down, roofing adhesive and then roll down the roll roofing on top of it. Or the preferred method is to actually heat it up with a torch. And you can see how this is all gets sticky. The asphalt right here would start to get kind of heated up and sticky itself. It's rolled out and it seals itself down, and that's the preferred method over there. Then we have the standard asphalt shingle. Here's the composition right there. It's got that self-sealing strip right here. It's a couple of inches wide, and then you got a granule surface. We got your actual asphalt body or coating, and then you got the fiberglass mat or organic felt in the very bottom of it. And when you install these, you want to make sure that these gaps right here are not, again, immediately in line. They always need to be offset. So the next shingle would have its opening strips like right in the center here. Oops. And then it would be overlapping that far so that the shingles could actually self-seal down. So usually in the winter, it takes a while to get it done, but the sun does warm it up enough so that it'll self-seal down. And certainly during the summertime, it's a lot easier and quicker that the shingles actually do seal themselves down pretty quick. So we look at an architectural shingle. For the most part, architectural shingle was a nicer look. And certainly would be on perhaps a more expensive home, but not always. This particular case, I kind of like to see right over here, we have a ridge vent, which allows the heat to escape from the attic space out through the top, instead of all those wind vents and electrical power vents that Georgia Power would charge you to take the heat out of your attic. So yeah, once we have a wonderful looking product, there are going to be some folks that are going to come in and say, well, we can make it cheaper, and we can, we can garner some of that market. So the introduction of Atlas Chalet shingles was done, and this is what came up as a result of a poor manufacture. You can see here on the left side, so when we're walking the roof, or when we're up there and we're looking at our roof from a ladder or other methods, we would see these blisters that would be evident on an Atlas shingle, and we would also see the cracking of the shingles that would be like here. It was just basically a defective product, and they kind of got ahead of the class action lawsuits that came against LP siding earlier on in construction, and also polybutylene piping was another one. These guys got out ahead of it and realized that they had a poor product, and they jumped out ahead and they said, well, okay, we'll go ahead and replace the shingles for you. But what the small type says was, yeah, they will provide the material, not necessarily the labor. And as we all know, when it comes to most items that involve construction, the labor is the more expensive part of the process. So removal of all the shingles and hauling them away into the dump and the reapplication of the shingles was where all the money was. Okay, so let's look at our wood shake shingles. Again, depending on the thickness, would depend on their life expectancy. So we see them here, different types of actual wood shingles. We got slate tile shingles. We got a Pennsylvania slate, which is about 35 to 75 years in life expectancy. Little thicker one from Vermont, 100 years, and 175 years from the Virginia. So slightly different colors in all of these shingles. Issue here is that, again, this is a product that you couldn't really walk on when you inspect a roof. They're brittle, and many times they've been on there for several years. It takes a special kind of construction in the attic with the support of the rafters and the sheathing in order to install these slate tile roofs. And we also deal the same thing with being brittle and cannot be walked on, would be the clay tile. Wonderful product, looks terrific, and again, cannot be accessed without special scaffolding, which is beyond the scope of what we would do as home inspectors. We will do our inspections, according to ASHI standards, which we'll cover in a moment. As I mentioned, sheet metal roofing is starting to make a big comeback. We're seeing some subdivisions that actually are being built up in Alpharetta, Roswell area that are what we call farmhouse looking roofs, and this is the way they're done. So here we go. Do we actually get on the roof? Well, only if it's accessible and safe to do so. And there are other methods to provide information about the roof, which we'll share with you now. So would you walk on the wood shingle or slate or clay roof? Most times not without special equipment, simply because it's too brittle or slippery. So we do our inspections to the American Society of Home Inspector Standards. And here we are having a look at what we are supposed to do. So you can see the inspector shall inspect readily accessible, visually observable, installed systems and components listed in the standards. And then we'll provide the written report and we'll describe how we inspected it and things like that. So if the roof was not able to be accessed safely, there would be a limitation comment in there. And the limitation would say the roof is too steep to safely access. Doing so may also cause damage to roofing materials without specialized equipment. The roof covering can be evaluated as a whole, and leaks would be evident from the interior space, and this area is scrutinized when the roof is not accessible. So that's the limitation that we would have there. We've actually been able to go about a different method as well, which we'll cover in just a moment. So here we would describe how we looked at the roof with binoculars from the ground and from the roof edge if our ladder was able to reach up to that height. So here we are. We're not required to be there, but here we have our home probe inspector. He's on that roof. We climbed up on the side here where this little structure was and was able to get up to here, and then perhaps slide ourselves up to the top of this one right here. So when we can, we will, but it's actually not required through the standards. All right, so how would we look at the roof and tell you about our issues if we weren't able to walk it? Well, you know, we'd go inside the attic, of course, and then we would see where there had been a leak. And, you know, when we see this, just to kind of mention to you, this was in a home that had a disclosure that said there were no roof leaks. But they obviously had known about it. They had actually put up a little catchment pan here in the attic to catch the water. So perhaps it wasn't exactly a truthful disclosure. Best to say didn't know. Inside the attic, again, you can see here the darkened spots where it's wet. And they even had a couple of buckets right here to catch that water on this particular roof right here. We would see water stains inside from roof leaks. By the way, you know, there are different types of testing machines that we have now that we can actually tell if the roof leak is still active, and we can put that into the report. So here we are. We have drones. Every home inspector with Home Probe has their own drone, and this is the way that we will always be able to guarantee you an image from above the roof. And these help out tremendously on these really steep roofs or the roofs that have the type of materials that we can't walk on. It's kind of fun thing at Home Probe. Everybody was actually able to name their drone. I happened to choose Ethan. So Ethan was chosen by me because I figured if it was a mission impossible for me to get on the roof, I could send good old Ethan up there and we would be able to take up pictures as needed. So, you know, this is where we would be able to tell about the shingle had lost the granules and therefore was at the end or very close to the end of its life expectancy. And then perhaps there would be a renegotiation, you know, with the budget on how to approach that particular issue. Multiple layers. You know, this of course is what we spoke about in the beginning about the weight on the roof, which causes the sagging. Some patching that went on there. We could see on this particular picture here these little white streaks that we see, and the discoloration. We've lost the granules on this roof, so that's another common problem. So, you know, we talk about what type of roofing material: asphalt shingle, metal and aluminum flashing, and binoculars from the ground. So here we can see a couple of good drone pictures from above. So you can see the condo townhouses here. So there would be no way for us to get up onto that roof. But the drone does get up there and show what we need to share with our client. One of the things that was really important for us to do was to be able to look at these plumbing vents here. You can see the actual flashing is metal, but it has a rubber gasket, and the rubber gasket's life expectancy is about 8 to 10 years. Well, you know, the life expectancy of roll roofing is the shortest, which is at 10 years. And you know, the rubber gaskets split and get deteriorated beforehand. So it's great that we can get up there with our drone and have a look at these. Simple fix, of course, is to apply some asphalt caulking at the top, which is a simple way of doing a repair. Recommended probably would be replacement by a qualified contractor to get up there and replace that particular flashing unit. So beware of the drone hackers. So I happen to be I can share a little story with you quickly before we end off. I was doing a condominium over in the Buckhead area, and I was taking a picture of the top of this very tall building, and my drone just took off, and I could do nothing to stop it. Across the street was a school, and I could see the drone heading off toward the woods behind the school. And basically, I figured I was going to go back and pick up what was left of my drone. They assigned a person to me. We went to the back of the school, and it was nowhere to be seen, but I kind of rebooted my phone, which is the way I operated the drone. And I noticed that the camera was still working. So I pushed up the button to raise it off the surface where it was. And sure enough, the drone had actually landed on the roof of the school. I brought it back to me, and it was in perfect shape. We walked back through the hallways of the school, and I passed by a classroom full of young kids that were all snickering and smiling when they saw me walking by with my drone. So these little people, for the lack of a better explanation of what I really thought of them, had hacked my drone and had taken it and shot it over the top of the school. So here we are at the end of this particular webinar, and Melanie will be jumping in here to give you a couple of messages about our upcoming webinars. Go for it, Melanie.
Hey everyone, so if you have questions about the roof, put them in the Q&A or in the chat, and Rael will stay and answer all of your questions. I wanted to give you two pieces of information. The first one is in terms of roofing. We are one of the last of our kind. Our inspectors still walk the roof when it is safe. So the first rule for them is to come home safe for dinner. And so if walking the roof will lend itself to getting home for dinner, they still walk the roof. And we also guarantee clients a picture from above the roof. And so the way that we're able to give that guarantee to people is because we use drones where it's not safe to walk the roof. We will never tell you you need a roofer unless something tells us that you need a roofer. We don't just say it's too high and too steep for us to see. So I love the way that we inspect roofs, and we've seen a ton of them lately. I also want to tell you, if you liked this class and if you like these ideas, you need to come hear Rael tomorrow. He is going to be talking about electricity. And one of my favorite ways to think about electricity came from the owner of the company, Jeff Luther, who was teaching a class once. And he compared electricity to teenagers. And they're all like having a party and they want to be everywhere. And you have to tell them where to go and what to do in order to keep it safe. And so we'll hear a little bit more about grounding, which you may have heard with your teenagers before, or you may remember back to your teenage days. And Rael will talk tomorrow about how we keep that electricity in line and how we ground it when it might become unsafe. So I really invite you to click on the link tomorrow. We're continuing this series through the end of the month, and it's culminating with a live inspection. So I love that you can ask your questions without a client there. We're always happy to answer questions, whether we're on a webinar or not. So thanks for coming. And I will turn it back over to Rael to see if we have questions.
I noticed that we just had one sitting in the Q&A, and that was if we could share the slides. And so I'm assuming that Barbara would handle that side of it.
Yes, and Rael, there's also a question in the chat, a roof question.
Okay. I'm looking for the chat. I don't see it.
You know what, why don't I just read it?
Sure.
It says the EPD type of roof reminds me of the same product used in crawl spaces now when encapsulating that space. Is it the same product or does it just look similar?
It does look similar. It's thicker, and it's a glue down operation that has seams in it, of course, that would have to be sealed a little differently from what we would have on our crawl space. But yeah, it is a similar. The actual stuff that's in the crawl space is just a plastic, thick plastic. You know, plastic comes in various thicknesses, but the EPDM is a totally different product. They just look very similar. Anything else?
Those are all the ones that I see. I think we're good.
Well, Ada, it was amazing that I covered all the bases, else everybody was asleep, one of the two. But thanks a lot for being here, folks. Hope you'll check us in again tomorrow for our electrical webinar, and have a great day.
Bye, everyone.